Hello there. My name is Shane Adams. This is Math 423, Class D01, Week 3 video demonstration. The first proof I'm going to do or talk about is to prove that if A is a generator of group G, then A inverse is also a generator of that same group. So first thing we're going to do is define the group. So let G be a group and also that A is an element within that group G. Excuse me. And we're going to define A as a generator of G, also denoted right there. So let P also be an element of G, and P is going to equal A to a power of P for some integer of P. So recall, to be a group, for an element A in G, there must be an element B in G such that A times B equals B times E, which equals the identity element. So since P is an element of G, then the inverse of P exists, and the inverse of P is also an element of G. Now we're going to define P is equal to A to the P power, which we did earlier. So then P inverse should equal A to the inverse of P. So now we're going to let P inverse equal to Q, which therefore means Q is going to equal A inverse to the P power for some integer P. Since Q is an arbitrary element in G, then any element in G can be expressed in terms of A inverse. Therefore, G is generated by A inverse and is denoted in the same fashion as A. Excuse me. Second one we're going to do is we are going to encrypt the message attack expected using permutation. And the permutation we're going to use is pi equal to 1635742. So first thing we're going to do, which I've already done for us, is we're going to separate the original string into two strings of 7. So we have that right here, and then separated by the double bars, and then the second string. And then we're going to give each column a number. So 1 through 7, and then 1 through 7 as well. So if we go ahead and write this in the normal fashion, 1 maps to 6, 2 maps to 1, 3 maps to 5, 4 maps to 2, 5 maps to 7, 6 maps to 3, and 7 maps to 4. So the actual encrypting of the message. So we are going to put the 6th letter in the first column. We are going to put the first letter in the second column. Then we're going to put the 5th in the third, the 2nd in the 4th, 7th in the 5th, 3rd in the 6th, and then the 4th and final in the last slot. So the message will then turn to, this is going to be a K, A, and then 5 is C, 2nd is a T, 7th is E, 3rd is a T, and the 4th is A. And then for the second string, we have an E, X, T, P, D, E, C. So that is the solution for our encryption of the original message attack expected using this permutation, and then our encrypted message is below.